Hi everyone, in this video I will be talking about how SHAP feature importance library works. At least I will try to explain the theory behind it and how it's related to game theory. And in this video I will be talking about how math works, how the math of it works with an example. And then in the second video I will try to explain it via using only NumPy. So I will try to code it on NumPy. Well, it may have some error on it, but I will try my best. Interpretable machine learning is not not uh, an area that you can find theoretical tutorials easily. So I will try my best. If you can see an error, you can inform me. Well, in this video, what we'll be talking about is SHAP, but in the theory behind it, we have actually a Shapley values that is actually more, you may be more familiar with it if you are familiar with the game theory. And the idea behind it is to distribute some payouts to employees, let's say. And to illustrate it, I will use some football example. So let's say that we are in a building of Manchester City. So we have some rooms, and Pep Guardiola is out of the building. So now the City is the champion today, and Guardiola says that I want to give some, sorry, perfect cloud talk. So Pep is a little bit confused, so that's why this cloud is a little bit bad. So Guardiola says that I want to give some bonus. And he wants to give it fairly. Pep is an intelligent guy, so he wants to make it a clear way. So actually, it's nice to choose Pep Guardiola because of bald head. I'm sorry. So we have Pep here, and here also some assistant coach of Manchester City, and they have some conversation again, and he says that without Kevin De Bruyne, we couldn't be champion. We couldn't won. And let's analyze the table. So let's analyze the leaderboard. And as of today, the leaderboard, should be like this. We have we have Manchester City at the top with 80 points, and Manchester United have 70 points in here. And it goes that way. So maybe the details are not important, but the information of the coach, the assistant coach, is important. Without Kevin De Bruyne, we couldn't win. So Pep is aware of that. Pep knows that some players contributed a lot this year. So this is, let's say that there are 4 people that they would like to focus on. First one is Kevin De Bruyne. The second one is I like, I think, the best striker of the season, Raheem Sterling. And we have, let's say, İlkay Gündoğan, and the maestro, Riyad Mahrez. So we have four people here. So Manchester City would like to distribute some bonus, and they have some estimates on what would be the scores with or without some players. So there are four people there, and let's say that the seven people fixed, the other seven people fixed, plus we have these four players, and there are some people. If in this combination here, let's say that we have three, there is some other player, let's say Phil Foden, that doesn't contribute a lot. I'm sorry. I know that he contributed a lot, but for a mathematical perspective, let's say that he doesn't contribute a lot. So Riyad Mahrez is better, but Phil Foden is zero. So if in this combination in here, if we have some players that is not in the subset, is not in a smaller subset, we have some players that won't have bonus. Okay, but it will be in the uh, first 11. Okay, we have players here, and we know that coach says without Kevin De Bruyne, the intelligent guy. I'm always comparing with Mesut Özil, but probably he is better. Kevin De Bruyne is better. The prime Kevin De Bruyne is better than Özil. I'm a little bit confused, but please comment on that on YouTube. So we know that without Kevin De Bruyne, City couldn't won. So he says that, and what he means by that is that in this subset, let's say that in here, without Kevin De Bruyne, City wouldn't be able to collect 70 points. So that's what the coach means actually. So Pep says that, oh yes, I'm fine with that. Pep agrees, and they try to uh, create scenarios. Coach and Pep try to create scenarios because they are very intelligent. Let's delete Phil Foden here, and they say that we have let's create some subsets, and the first information that we know is, let's pick some random color that I think that it will be nice, but it probably wouldn't look good. So let's say that our first subset is if we have no players from here, from these four, we would collect, let's say, 45 points. So this will be a very bad disaster. And let's say that we have another subset that only includes Raheem Sterling, that ends up with 58. And if we add a subset that includes Raheem Sterling with Sergio Aguero, do we include him? I'm sorry, it will be İlkay Gündoğan, let's say. So they would collect 64 points. And the last information could be that, uh, at least in here, the last information could be that without Kevin De Bruyne, if all the players included, Raheem Sterling, İlkay Gündoğan, and Riyad Mahrez, they know that they couldn't be a champion because coach says that. So they will place in here with 69 points, let's say. Okay, so in this subset we have 69. Sorry, 69. So let me fill these blanks after stopping. So I just have some changes in this table. So Pep and his assistant coach have some function that determines, with respect to some subset, they know what points they will get at the end of the league. So this is the end of 2021 season. Probably there's no match, or maybe there's some match, but City just guaranteed to be a champion. So Pep and his coach knows that if I have some subset of my offensive players, and I know that the points that I will be receiving at the end of the league is these points. So I have made some changes here, but at the end of the day, they would like to distribute some bonus to these four people. So they would like to know how to distribute it. So they uh, they just get a consultant service from the author of Shapley value Shapley library. Sorry, they just go to the University of Washington, but uh, luckily I'm here. I'm not a good person to find it, but I will try my best at here. So Pep talks with me. Let's say that here I am. Give me some function that to estimate these bonuses. So I try to use SHAP library and I try my best and I say that okay, I will do some some mathematical games and I will distribute the bonuses correctly. So I know that if all the players included in the team, I will have 80 points as I have at the end. But if I just couldn't get Kevin De Bruyne, I wouldn't be a champion. So I would have maximum of 69 points. But I have the exact number. I will have 69 points. So first, there are how many options we have, how many subsets we have. So we have four people here. So all the options would lead to 16 scenarios. But uh, without the Kevin De Bruyne, let's say that I would like to estimate the scenarios that I don't even have a Kevin De Bruyne on the coach. I would have 2.2 or 3. We have 8 options, right? So I actually need to think all the scenarios that Kevin De Bruyne is not there, and I would like to add Kevin De Bruyne to these scenarios, and I would like to estimate the effect of Kevin De Bruyne on these points. Okay, let me try to do it, and let me not focus on all the possibilities, but some cases that I can I can estimate the effect of Kevin De Bruyne by observing the scenario that is not including Kevin De Bruyne and that is including Kevin De Bruyne. So this is one of the combination that I have scenario with Kevin De Bruyne and without Kevin De Bruyne. And I know that the effect of Kevin De Bruyne in this scenario is 67 minus 62, right? And I would like to estimate the effect of uh, choosing a large or small subset. Now I have four people, but in the scenario that I have only that I have no Kevin De Bruyne, I have two people. So there are two information I have. There we have four people, but in the scenario in the subset we have two people without Kevin De Bruyne. So that's what I'm comparing right now. These two. So we have no, and normally we have four people, but in the subset we have two people in here in the small scenario. So we have 2 factorial multiplied by 4 minus 2 minus 1 factorial divided by 4 factorial. So maybe this could be familiar to you. This is actually the inverse of um, combination. So with that assumption, we know that uh, if we have a lot of people in subset, the effect of it will be large. So if I have a large effect, and if we have some combination, if we have large subset, the effect of it will be larger because if we don't have anyone, and if we only had one people, uh, the effect of it will be larger because yeah, it's the one is better than nothing. But as I add more and more people to these subsets, more and more people, I have some increments in points. So this is more valuable. The effect when a lot of people in subset, and if I add another person inside of it, so the effect of it will be larger. So that comes with the combination here, inverse combination. So this is one of the scenarios that I'm talking, but also there are scenarios that includes all others and also includes Kevin De Bruyne, right? So I can add this scenario to the uh, scenario I mentioned. So I'm trying to estimate the effect of Kevin De Bruyne, and I'm saying that the amount of point I receive with Kevin De Bruyne is 80, but without I couldn't be a champion. So I have 69, and I multiply it by the inverse combination of it. So I weight by that, and what I end up with in here we have 3 factorial. I'm just having the inverse combination here. Factorial 4 minus 3 minus 1 factorial divided by all set, right? So, mm, so idea is actually pretty straightforward, and let us formulate it. And let's say that the bonus is notated as here, and the bonus of Kevin De Bruyne is here. So what I have done is, at first I thought all the scenarios. Oh, sorry, this is too large. At first I thought all the scenarios that doesn't include Kevin De Bruyne, and then I add them to see what Kevin De Bruyne affects, right? So first I thought all the subsets that include that doesn't include Kevin De Bruyne in Manchester City. I'm sorry, in Manchester City. So I have 8 scenarios for that. We've talked about it. So I thought these scenarios. So in this subset, I just inversed the combination of of uh, the number of all people in city. I know that it's actually 4, but let us formulate uh, in that way. Let's say that in our Manchester City, we are just talking about these 4 people, let's say. So we are thinking these scenarios, and we just think this. Let's say that the thing that we have done in here have some formula. Okay, so we just estimated their effect, right? So estimated the individual's effect or subset effect in the Premier League table, right? So let's say that we have a function w. Let me notate it with different color. Function w that maps all the powers set of Manchester City, all the subsets, and maps it to some real value. The real value is on here, the leaderboard table, the numbers in the leaderboard table. And this function takes, let me explain right in that way. This function takes some subset, Kevin De Bruyne and Raheem Sterling, and sorry, and returns the point. So it's 64, right? So for this subset, I have 64. So the W function or profitability function in Shapley values takes the subset, takes the combination, and returns the result of it. So In at the end, we have in the general form, we have profitability function that takes a subset that doesn't include Kevin De Bruyne and compares it with the scenario if I add Kevin De Bruyne, what would be the point? So this is a union. Sorry. This is the sign of union minus profit or the point that I get without Kevin De Bruyne. So this is the bonus of Kevin De Bruyne actually. So in general, I have this formula. I have some phi that takes profitability function actually and scales it with respect to number of elements in my whole set, and I just sum all the scenarios that doesn't include the people or the feature actually that I would like to estimate its importance or bonus, and just think all the scenarios with and without that. So that's how the Shapley values works actually. So how does it relate to machine learning or SHAP values? This is actually fairly easy. This is actually fairly easy. Uh, how it's done is actually like that. Replace Kevin De Bruyne with most important feature, or one of the features, let's say, most important feature in machine learning model, and replace all other players with features. So our players actually, so in Shap, you may relate it to Shapley values, sorry. Our players actually features in machine learning, and our payout or bonus is the effect of feature on local prediction. So when we code with SHAP library, we will see that the ML model, let's say that there's some range of prediction. Let me have some more uglier color. Some prediction that I can see that the average value of prediction is here. So let's say that it is 650. And I see that some feature, let's say that this is weather on that day, contributed. So this is the average prediction. This is the baseline. But I predicted uh, some value for, let's say that electricity consumption as 683, right? So the maybe weather push it to 700, but I have some other phenomena. Let's say that this is also wind. Some phenomena that uh, in low wind value I have less electricity consumption that decreases from 700 to 683. So the effect of feature on local prediction is actually our payout or bonus, or the effect of Kevin De Bruyne on the leaderboard. So without Kevin De Bruyne we have 69, but with Kevin De Bruyne we are the champion. So that's how SHAP works actually. In theoretically we are just competing these features. So in this example we are competing with these players, but in SHAP we have features. So you may have some questions that uh, you know, uh, in machine learning model we have uh, fixed features generally, or maybe in trees we have in decision trees we may have some tricks to deal with it, but in, let's say, the neural network, we have fixed amount of features. So our feature set is fixed. Even at the beginning, I have some n features, and this will always go like that. So in that case, I just replace feature with most non-informative form of it. Let's say that in our case, we have weather, and we just replace uh, weather feature with the mean of weather feature to make it like an empty subset. So to make it like a scenario that weather doesn't exist. So we will be dealing with it on coding it with NumPy. But the general idea of Shapley values actually mentioned here. So it's the baseline of the SHAP values or the SHAP library. We are just computing the features, and we are trying to find out how these local predictions are affected by uh, features, and how much these features uh, affected on these prediction.